Tau Ceti is one of the closest sun-like stars to Earth, about 80% the mass and radius of the Sun and about 12 light-years away from us. Because of this close distance and similarity to the Sun, this star is one of the most commonly featured systems in science fiction, and because of that, a lot of people have tried to find out what planets exist in the system. For a while this was going pretty well, and only a few years ago, there were as many as 8 candidate planets around Tau Ceti, ranging from small rocky planets to large gas giants. If all of these planets were real, it would tie Tau Ceti with the solar system in Kepler 90 for the largest number of known planets in a single system, which is pretty exciting. And most notably, 2 of these planets, Tau Ceti E and F, were in the habitable zone where temperatures are right for liquid water to exist. Unfortunately, I have bad news. None of the candidate planets around Tau Ceti have been confirmed, and none of them are even likely to actually exist. Several of them have been refuted, and even the existence of the habitable zone planet Tau Ceti E is dubious at best. So, what's happening at Tau Ceti? Is there any hope for any of the current candidates to actually be real? And if there isn't, is there anything we can say about what potential planets could exist here? First, we'll go over all 8 of Tau Ceti's planets and their chances of actually being real. Also be aware that because of the way these planet candidates were detected, only their minimum mass is known, meaning we don't know how big they actually are. But we know that they are definitely bigger than a specific mass. The first planet was Tau Ceti b, a hot planet at least 2 times bigger than Earth, orbiting at about 1/10 the distance Earth orbits the Sun, closer to Tau Ceti than Mercury's orbit. Its existence was proposed in 2012 along with Tau Ceti c, d, e, and f, which we'll get to later. If real, it would have taken about 2 weeks to orbit the star. However, a study from 2017 tried and failed to detect Planet B. But interestingly, a different paper also did an analysis of the system based on the other known planets around other stars, and seemed to suggest that based on all known Tau Ceti planets at the time, it was pretty likely that a planet similar to B could exist. Essentially, considering the patterns of the orbits of other planetary systems, it seemed likely that a planet with a similar orbit to Tau Ceti b could exist. Tau Ceti G is the next planet from the star, and it was suggested to exist in the same paper that didn't detect Planet B. It's called G because at the time of its discovery, planets B, C, D, E, and F were all still considered candidates. It has a minimum mass slightly smaller than B at 1.75 Earth masses, and takes about 20 days to orbit the star. Like B, if the minimum mass is close to the true mass, this would likely make G another hot rocky planet. Planet G, unlike B, is still considered a candidate and has not been refuted yet. This is because later studies found very weak evidence for a 20-day planetary signal around Tau Ceti, which if real, would correspond to Tau Ceti G. However, this signal was too weak to be considered statistically significant, meaning it could not be used to confirm or disprove the planet, making the existence of Tau Ceti G dubious and unlikely, but not fully disproven yet. Tau Ceti C is the next candidate from the star with a significantly larger minimum mass than B or G, of at least 3.1 Earth masses. This could make C a rocky planet or potentially a mini Neptune, assuming it actually exists. Unfortunately, Planet C almost certainly doesn't exist. The signal used to detect it is correlated with Tau Ceti's rotation, meaning it could have been stellar activity mistaken for a planet. However, like B, a later analysis of the system, assuming the 2017 4-planet model, suggests that a planet with a similar orbital period to C is likely to exist. However, it's still unlikely, and like B, Tau Ceti C is not currently considered a candidate. Tau Ceti H is the next planet from the star, and it has a minimum mass of about 1.83 Earths between B and G. If real, it would take about 50 days to orbit Tau Ceti, and like G is still considered a candidate and was found in the 2017 paper. Follow-up observations haven't detected the planet, unlike G, but it's close to the detection limit of the telescopes used, so it could theoretically have been missed. So like Planet G, Planet H is dubious at best, but not fully disproven yet. Tau Ceti D is probably the least likely to exist. Follow-up observations failing to detect it in all data sets. If this planet was real, it would be the biggest one so far with a minimum mass of at least 3.6 Earths, with an orbital period of 94 days. But, if I had to guess, I would say this planet probably doesn't exist. But now it's time for the moment you've all been waiting for. Tau Ceti E. The first planet close to Tau Ceti's habitable zone, and if real would provide some evidence in favor of planets B, C, and D. This is because the 2017 four-planet model assumes that Tau Ceti E, F, G, and H exist. So if even one of these planets doesn't exist, it would mean that B, C, and D probably actually aren't that likely either. Well, first off, E's minimum mass is 3.93 Earths. Rocky planets rarely get this large, and keep in mind that is the minimum, and E could be significantly larger. In fact, Tau Ceti likely faces Earth pole-on. Since planets usually orbit their stars' equators, this will mean that significantly larger true masses for all of the planets are likely. Luckily, however, this is unlikely for two reasons. One being Tau Ceti has an asteroid belt that is inclined by 35 degrees, making it likely that any planets have a similar inclination, which would lower their true masses. Second being, a 2023 study suggested that, if the planets do have equatorial orbits, they would have to be so large that it would cause the entire Tau Ceti system to become unstable in just 10 million years. Given that Tau Ceti is 8 to 10 billion years old, this is unlikely, and it seems that the planets likely have smaller masses closer to mini-Neptunes than gas giants. Given this, I would personally guess that Tau Ceti E is a warm mini-Neptune and not a habitable rocky planet, assuming it exists. It's about half an AU from Tau Ceti and receives a similar amount of light Venus gets, giving it a temperature of 154 degrees Fahrenheit or 68 Celsius. But none of this really matters because a recent study failed to detect Tau Ceti E, despite the fact that the telescope used should have had no problem doing so. This casts serious doubt on the existence of Tau Ceti E. Tau Ceti F is the next candidate, and there's a large gap between it and where Tau Ceti E would be. F is about 1.3 AU away from its star, further than Earth and close to the distance Mars orbits the Sun. It takes 642 days to orbit and has the same minimum mass as E, at least 3.93 Earths. However, assuming that F has the same orbital inclination as the asteroid belt, its true mass would be between 5.56 and 9.3 Earth masses, putting it well within the mini-Neptune range. F only receives about 28% of the light Earth does, unlike E, which would have received 91% more if it was real. This actually does narrowly put planet F in the habitable zone, but given the fact I would guess it's a mini-Neptune and not a rocky planet, it's probably not habitable. Tau Ceti I is the last current candidate planet of the system and is different from the others in that it has a maximum mass instead of a minimum mass, and that maximum mass is 5 Jupiters. For comparison, 3 to 20 AU is roughly the distance between Jupiter and Uranus. Observations of the star by Hubble go back to the 1990s and rule out the presence of any large planets with orbital periods of less than 15 years. This means that if Tau Ceti I does exist, its orbit would have to be at the longer end of the 3 to 20 AU range. As I talked about in my Planets of Vega video, which is similar to this one, a star's metallicity is extremely important to planet formation. Essentially, the more elements heavier than hydrogen and helium a star has, the more often large gas giants form around it. However, it doesn't. Tau Ceti's metallicity is significantly lower than the Sun's. This means that not only will planets have a harder time forming around the star, the planets that do form will on average be smaller. It's also important to keep in mind that 5 Jupiters is a maximum mass, not a minimum like all the other planets. So it could conceivably be much smaller and avoid much of the metallicity issue, though it would still be a problem. So those are all the current planet candidates of the Tau Ceti system, and as you can probably see, we've had a lot of bad luck finding planets around the star. Planets B, C, and D probably don't exist, but their existence becomes more likely if planets E, F, G, and H exist. But E and H haven't been detected. G was only detected extremely weakly, if at all, and F is below the detection limit, and can't be confirmed or ruled out right now. We know large gas giants in the system are unlikely due to the star's low metallicity and Hubble observations, but this has happened with other stars before. Barnard's star, for example, has had a complicated history of refuted planets. But only a few months ago, we finally definitively confirmed 4 small rocky planets in the system. If I had to guess, I am optimistic that Tau Ceti does have planets. But I wouldn't be surprised if they are all small rocky planets with very few, if any, planets much larger than a mini-Neptune. This would explain why we haven't confirmed any planets yet, as they'd be too small to be detected with modern equipment. For now, we'll just have to wait until more studies of the system can be performed. Though one interesting thing I'd like to mention is that, even though most of these planets are refuted, the letters of each are still going down the alphabet. I think it's kind of funny that we could end up in a world where Tau Ceti's only confirmed planet is like Tau Ceti L, which would suggest it's the 11th planet in its system. But with that, that's where I'll end this video. Hopefully we're able to find planets around Tau Ceti soon or confirm any of these candidates. Thank you for watching. If you enjoyed, check out my other videos about exoplanets and space exploration.